Okay, we've got question 3 on functions defined by integrals. So we have the graph of a differentiable function f on the closed interval -4 to 4. Let g of x equal the integral from -4 to x of f of t dt. So whenever you start these, if you have it on paper, always box this equation. If you don't have it on paper, please go ahead and pause and copy this equation for me. So go ahead and hit pause and copy that. And then before we even read parts A through E, we want to derive both sides of the equation. So the derivative of the left side is going to be g prime of x, and the derivative of the right side is an FTC, right? So derivative of an integral, that's just going to give me f of x. So we've got g prime of x equals f of x. In other words, yes, this is the graph of f, but it's also the graph of g prime. Okay, so now let's go parts A through E. So A says find g of -4. So would we use given or derived equation? Given. We want g of -4, right? So I'm going to grab the given equation and just replace any x's with -4. So now I have the integral from -4 to -4 of f of t dt, which means typically I would come to the graph of f over here and find the area from -4 to -4 in this case, but have we captured any area? No, we haven't moved at all on the x-axis, so the answer is 0. But if I went from -4 to -3, we would be looking at that area. Just an FYI there. Okay, now part B says find g prime of -4. So this time we're going to go to the derived equation. So g prime of -4 equals f of -4. So coming to my graph here, this is the graph of f. So f of -4 is 2. All right, part C, on which intervals or intervals is the graph of g decreasing? Justify. We were not given the graph of g, we were given the graph of f, which is equal to g prime. So if I want to know where g is decreasing, that would be the same as g prime being negative, so below the x-axis. So for part C, we can go from x equals 1 to 3, and my justification is since g prime or f, you don't have to state both since you've already stated that they're equal here, but either one, just make sure you don't say it. So since g prime or f is negative there. So then part D, on which interval or intervals is the graph of g concave down? Justify. So if I want g to be concave down, the given graph g prime will be decreasing. So that'll be from -4 to -3 and from -1 to 2. So for part D, from x equals -4 to -3 and from -1 to 2, since g prime or f is negative there. Oh, I'm sorry, it's decreasing there. Part E says for what values of x does g have an inflection point? Justify. So inflection point on g would be where g changes concavity. Maybe. It's really not happy with me. Okay, whatever. So that means g prime would be changing from increasing to decreasing or vice versa. So just be really careful. We go from decrease, switch to increase, then we switch here again and here again. So just be really, really mindful with those. So we're going to have x equals -3, -1, and 2, since g prime or f changes from increasing to decreasing or vice versa there.